Here's question number 15 from homework. A doctor released the results of clinical trials of a vaccine to prevent a particular disease. In these trials, 200,000 children were randomly divided into two groups. The subjects in group 1 were given the vaccine, and subjects in 2 were given a placebo. So, uh, two groups are completely random. Of 100,000 group in experimental group, 21 developed the disease, and in 100,000 children in control group, only 63 developed the disease. Let's answer the question. So one group was experimental with the vaccine, other group was with placebo. Both groups had the size of 100,000. So those are n values. X values for the first group. 24 children contracted the disease and 47 contracted the disease in the case of placebo. What type of experimental design is this? It's completely randomized, right? Because children in the first group do not have anything to do with the second group. So that's your answer. What is the response variable? The response variable is did the subject contract the disease or not? Because what is happening here, what are they telling? That they developed the disease or not. So that is the response variable. What are the treatments? Either they are given vaccine or placebo. So those are the two treatments happening in two groups. What is placebo? A placebo is not a pill. It's a innocuous medication. It's like pretend medication. Why is such a large number of subjects needed to this study? Let's read through the options. The number of subjects is so large because large sample size is needed to ensure the samples are independent. That's not true. We need smaller samples to make sure they are independent. Number of subjects is so large because there is low incidence rate. I think this is the possible answer. The number of subjects is so large because these clinical trials which require significant number of subjects. Vaccine is very effective. We do not know that. We do not know anything about vaccine efficacy. Okay, so that is the correct answer. Okay, what are the conditions? The samples have to be independent. Yes. Then we have the sample size is less than 5% of the population size, and this D condition also we need to check. So that is n times p1 cap times 1 minus p1 cap is more than 10, and 1 is 100,000. P1 cap is how much? P1 cap. So for P1 cap, you need to calculate first. It is 24 divided by 100,000. So that would be 0.00 024 times 1 minus 0.00024. Okay, so we can calculate that 100,000 times 0.00024 times 1 minus point. So that's more than 10. And similarly, you can check n2 times p2 cap minus 1 minus p2 cap is also more than 10. It's a simple calculation. Okay. Now, what are the hypotheses? What's the question? Identify null and alternate hypothesis for this test. P1 represents the P1 is for the experimental group. P2 is the proportion of the placebo group. Children given the vaccine who developed the disease, and P2 represents the population proportion of children given the placebo who developed the disease. And what are they trying to test? They want to see if the medicine is preventing the particular disease. That means we should test that the people who are taken the medicine, that is P1 group, proportion of those people is less than P2. So we are gonna say null hypothesis is always equal to high, An alternate hypothesis, we want to claim that proportion of the people who have taken vaccine are less getting disease than the proportion of people who have not taken vaccine, that is, have taken placebo. So null hypothesis is always equal to, this is less than type. Okay. Test statistic. Now we are there, we can use our, it's the proportion problem, it's two populations, so we need to use 2 prop z test, which is at number 6. We have 24 people out of 100,000 contracted disease and 47 people out of 100,000 of placebo contracted disease, and we want to test if P1 is less than P2. Then press calculate. So we have our test statistic is the z value in your calculator screen. That's negative 2.73. We need to put 2 decimal places. Now the p value is p here in your calculator. That's given to be 3 decimal places. It's 0.003. Now, how much was alpha given to us? Alpha was given to us as 0.005. So let's note that down in our board. Alpha was given to be 0.05. P value is coming to be 0.003, which is clearly less than alpha. So we are gonna reject. Let's see the interpretation of p value. So p-value is when the null hypothesis is true. That means if the population proportions are equal, one would expect a sample different proportion. So that is p1 minus p2. We want it in extreme. That means it has to be smaller than the absolute value of, because p minus p2, you want it to be negative, right? So one observation 0. Let's check. That is the correct answer, because p-value is basically, its definition is when the null hypothesis is true, that means when they're equal, then what is the probability of them going in extreme? Extreme is that the alternate one, right? So smaller than, because p1 is less than p2, and that is very small chance. That's why we are rejecting null hypothesis. Rejecting H naught. So answer is A or B. But if we reject H naught, this is happening. We are rejecting H naught. That means we are accepting H1. That means there is sufficient evidence. So we are going to say we are rejecting H naught and there is sufficient evidence for the population proportion of P1 to be less than P2. So reject H naught, and there is sufficient evidence at this significance that the vaccine is effective, because the disease, less people are contracting the disease, and it is preventing the disease.